Hello students, the question is a mass is attached to a thin wire and whirled in a vertical circle. The wire is most likely to break when the options are the mass is at the lowest point, second option inclined at an angle of 60 degree from vertical, third point the mass is at the highest point, and fourth option the wire is horizontal. First we will draw a vertical circle like this. This is the vertical circle. Okay. Now a body is whirled in this circular path. Mind it, the circle is situated in a vertical plane, and we take 4 points, namely A, this is the lowest position, the highest position is B, the horizontal position is C, and D is any position. Suppose OD is making an angle theta with OA, so I can say that the angular position of point D with respect to vertical is theta. Now let's find the expression of tension at these points. Suppose the particle has a velocity VA at point A, VD at point D, and so on, and we can say that the direction of the velocities will be tangential. And see one interesting fact here, that the velocities at different points are different. Now it is true only when we consider gravity in a vertical plane, but if we do not consider gravity, then these velocities could be identical, but here the velocities are different. And if I consider this as the reference level where potential energy is taken as 0, we can say as the body moves up, its potential energy will increase, and since the body is doing work against the gravity, its kinetic energy should decrease according to the principle of conservation of energy. Therefore I can write that from principle of conservation of mechanical energy, of course VA would be the maximum possible velocity the body will have at any point on the vertical circle. VA should be greater than VD, should be greater than VC, and should be greater than VB. Now coming to the tension. Now at point A, tension. Now at point A, if I draw the FBD of the body, weight is acting downwards, which is mg, tension acting along the string as if the string is pulling the body, so tension is this. Suppose the tension is TA, and there is a centripetal acceleration which is again towards the center, and it has a value of centripetal acceleration, it is a value of Vs square divided by R, where R is the radius of the path, or you can say the length of the string. Therefore the equation is TA minus mg equals to m Vs square divided by R. So we get the formula of tension at the lowest position, which is mv square by R plus mg. This is the formula of tension at the lowest position A. Now coming to the highest position, that is B. Now if I draw FBD of the mass at the highest position B, now see at the highest position mg will act like this, tension will also act in the same direction, of mg, and centripetal acceleration will be towards the center. So at point B we can say weight is downward as well as tension at B point, and acceleration is in this direction, which is Vb square divided by r. Clearly we can write Tb plus mg equals to m Vb square divided by r. So Tb, that is tension at the highest position, will be Tb square by r minus mg. That's the formula of tension at the highest position. Now coming to the horizontal position, which is C. Now see, FBD of the mass at C. C is the horizontal position, mind it. Now at C we can say that weight is downwards, tension is along the string and pulling in nature, so Tc, and centripetal acceleration is towards the center, which is Vc square divided by r. So expression is Tc equals to m Vc square divided by r. That's the formula of tension at the horizontal position. Now see, this is the formula of tension at the lowest position, m Vs square by r plus mg. At the highest position, tension is m Vv square by r minus mg, and at the horizontal position, the tension is m Vc square divided by r. Now we will analyze the formula of tension at any general point D. I again say that OD is making angle theta with the vertical line OA. So proceeding to the next slide, FBD of the mass at any general point D. You can say at D the angular position is theta with vertical. Now let's draw. This is D, this is theta. Now see, mg is downward, Td is like this, and centripetal acceleration is Vd square divided by r, which is towards the center. Now I will take component of mg, one in this direction, another is in this direction. If this is theta, this is also theta, corresponding angle mg cos theta and mg sin theta. Therefore from equation I can write Td minus mg cos theta equals to m Vd square divided by r. So Td, which is the general formula of tension at any position, is given by m Vd square divided by r plus mg cos theta. Now this is the general formula. Why general? Because see at this diagram, if at A position, the angular position will be 0 degree. So if I put theta equals to 0 degree here, I will get a similar formula of tension at A. So then tension will be mv square by r plus mg cos 0, which is mg. Now see, this is the same formula as tension at A. And if I go to C, then theta will be 90 degree. So if theta equals to 90 degree, I can get the formula at point C, right? At point C, this is the tension at C. And similarly at B, the angle is 180 degree. So at 180 degree, I can say that if theta is 180 degree, this tension becomes mv square by r minus mg, because cos 180 is minus 1. Now let's come to this problem. Here they ask you the wire is most likely to break at which point. See, the wire will break if the tension in the wire exceeds a certain value. What is that value? That is the breaking strength of the wire. Therefore, the wire is mostly likely to break at a point where we can get a maximum tension. And now see the formula of tension at A. mva square by r plus mg. Here plus mg is there, and I have already discussed that velocity at the lowest point would be the maximum possible velocity. Therefore, clearly the tension at the lowest point will be the maximum tension you can get in a vertical circle. Therefore, the wire is most likely, this is the maximum tension. So the wire is most likely to break at the lowest position. I hope you understand. So the answer or the correct option is option 1. Option 1. Thank you for watching this video. Please subscribe my channel Phi Solver.